Perfect. Well, thanks everyone for being here and caring about eliminating AI risk, which is something that obviously I care about very much, and we all care about very much at Robust Intelligence. Just to kind of get us started, so paraphrasing on what Mark Andreessen said, I think is like back in 2011, we're now in this place where, as we know, AI is eating the world, right? And one way to look at it is basically looking at the AI software market worldwide, right? And kind of like looking at how much it's been growing and how much it's going to continue on growing in the coming years, right? And obviously, for all of us being here, we don't need much convincing of the fact that AI is eating the world. But really, I think kind of like the biggest problem that we're facing right now is the fact that AI models fail all the time, right? And I think that like for anybody who's been using AI models before production, and certainly while these models are in production, they've become aware of the fact that just how brittle AI models are and just how often they fail. So what do we mean when we say that AI models fail? What we mean is prediction is coming in, or sorry, data point is coming in, and a prediction is coming out, right? But in many cases, right, that prediction could be erroneous. And we call these silent failures. So why are these models failing, right? Why are these predictions coming out wrong? Well, it could be mired like kind of various cases, right? So it could be that models fail because of some corner case inputs. It could be because models are making biased predictions due to the fact that they were maybe trained on one data set and now they're being applied on another data set. It could be that we have unexpected model outputs. So if you guys remember back in 2016, Microsoft released its chatbot, right? And this chatbot was taking input from Twitter. People figured it out, right? And they were basically inserting kind of all these sentences into Twitter, right, that made this chatbot become a racist chatbot, and Microsoft shut it down within less than 24 hours. So other examples could be that there's just simply a shift in data distribution. And a lot of us have seen that, especially during the times of COVID, right, when all of a sudden the distribution of the data changes dramatically, right, and these AI models are performing differently. We all know that there's adversarial inputs out there, whether you're running models for fraud detection or, go all back to the time of, spam and other ones, right, where we have like adversaries that are actively manipulating data in order to produce erroneous outcomes. And of course, there are kind of like different issues with broken data pipelines where the data gets manipulated and changed, right, and the models fail. So these are all just like different reasons for why input can change in a way that affects the model predictions and the model performance. So really, when organizations are adopting AI, right, what they're doing and what we're doing is we're adopting AI risk, right? So what is AI risk? So AI risk is the set of operational challenges, right, that we take upon ourselves that is not present in traditional software systems. Okay. So if we sort of like take a step back and ask ourselves, where is the pain, right, of an organization that is trying to introduce AI and rely on AI, right? So if we think back a few years ago to where we were in 2015, and you kind of took a survey on where organizations are. Right? So the major pain is in actual basic AI development. So what does that mean? That means that if you think about 2015, this is the time before TensorFlow, before PyTorch, before scikit-learn, right? Before we had all these ways of automatically creating, or kind of like very good frameworks for creating models, right? During that time, if you wanted to build a model, you had to hire somebody who is probably out of grad school, right, that knew how to code machine learning models in C++, right, and they would code like an SVM, and this is how you develop an AI model. So your biggest pain in 2015 was actually developing models. Fast forward to like 2022, right? Thankfully now we have a lot of frameworks, open source frameworks, as well as many others. We have companies like DataRobot and C3, right, and H2O that basically make AI development a non-problem for organizations, right? And the main challenge is now deployment, I have a model that's running on, that is doing something, has some sort of predictive performance and has some value, but now my main challenge is basically getting this model into production, right? But again, with especially standing in this conference, right, the problem of AI deployment is getting solved. And if we look, to where we're going to be, 2-3 years from now, the main problem that's going to remain for us as a community is AI risk, right? So the broken data pipelines are not going anywhere, right? All the, the adversarial inputs and all these sort of like different challenges with kind of like bias predictions and all these kinds of things, right? They're going to continue to stay as a, as a problem that we as a community are going to have to deal with on a, constant basis. So I think that the data and AI community, right, the focus should really be on eliminating AI risk, because that is the problem that will stay. If we think of cybersecurity, right, that is a problem that doesn't seem like it's going away and constantly needs attention. And a different way of saying, that we should focus on eliminating AI risk is saying that what we should focus on is we should focus on machine learning integrity. Okay. So if you have to leave in 30 seconds, or you have to zone out, or go on Slack or read an important email, I'd like you to stay and basically just sort of keep these 3 bullet points in mind as kind of like the main message of this talk. Okay? So here are kind of my 3 bullet points. Number 1 is that model failures due to bias, bad input, drift, adversaries, what have you, they're not the problems, but they're the symptoms of the problem that is AI risk. Okay? So that's number 1. So those are not the problems. They're symptoms of the problem, and the problem is AI risk. The second bullet point is that every AI risk symptom can be mitigated by an appropriately designed test. When I mean appropriately designed tests, I think about unit tests and think about kind of tests that we know from software engineering and cybersecurity, and I'll talk about those. Okay, but every one of these symptoms can be mitigated by a test. Okay, and then finally, the last bullet point is that testing is a powerful framework that we can create an entire system for preventing and monitoring AI risk, and that will give us ML integrity. And that's what I'm going to focus on for the rest of the 27 minutes that we have together. Okay. So I'm going to talk about what is a test-driven approach, right, and how we can kind of combine tests into a system that's going to help us get rid of AI risks to the best as we can. All right. So we'll start by talking about identifying what are the challenges that stand between us to achieving ML integrity. Then we'll talk about this testing-driven approach. We'll give some examples and case studies, and then I'll give you one slide on the main takeaways. Okay? All right. All right, so what are the challenges, right, to achieving ML integrity? So if we think about the ML lifecycle, right, largely speaking, we can kind of think about this in 3 stages. The first stage is the stage of data engineering. The second stage is the stage of model building, right? And then finally, the third stage is the stage of model operations. Okay. And every one of these stages has its own challenges that need to be addressed, right? And every one of these challenges are basically, they're basically kind of like a source for different model failures that can come up. So when we're looking at data engineering, when we open it up under the hood, then there's like basically data cleaning, data exploration, feature engineering that go all into this. And what could go wrong? Well, a lot of things, right? We could be facing broken upstream pipelines. We could be facing various outliers. There could be data leakage, feature selection, oversampling, right? These are all sort of like different challenges, right, in that part of data engineering that can introduce errors, right, for the model downstream. When we're looking at model building, right, that has the stages of training, evaluation, tuning, retraining. And basically here, again, there's just like, large collection of different issues that can come up, right? There are performance, we can have, various issues with performance on edge cases. There could be underperforming subsets. There could be bias against protected features that the model has because of, being trained on an inappropriate data set. The model itself could be vulnerable to data corruptions, could be vulnerable to evasion attacks. And basically, there's no really good way of creating a standardized decision process, right, to pick the best model. Finally, like when we're looking at model operations, this is when we have models that are now actually running in production, right? Again, we're facing multiple stages that introduce different issues and problems, right? There's the actual deployment of the model. There's the model serving, model monitoring, and then the actual, again, model selection for retraining. So here, basically, we're facing with issues of reproducibility, making sure the data is free of corruptions. We have issues with degradation of model performance. We need to kind of like estimate sometimes performance of models in the absence of labels, right? And we have to think about how we automate the retraining pipeline. So all these different issues, right? All these different steps and these challenges make us vulnerable to kind of like basically bad input that can affect the model performance. So all these technical challenges, they get translated into risk, right? So the technical challenges that we enumerated, some of which in data engineering, model building, model ops, they all become basically challenges with model performance, fairness, security, and transparency of the models. Okay. So how do we achieve machine learning integrity? What we want to think about is like as machine learning integrity, we want to think about something that is kind of like wraps around the entire process, right, of end-to-end process that goes of the ML pipeline in a way that kind of does its best to guarantee that models are not going to fail when generating these predictions. So in order to do that, we want to talk about like, a testing-driven approach for how to achieve this machine learning integrity. So before I'm going to talk about like the testing-driven approach, let me talk about what it's not, right? So what it's not is the alternative to a testing-driven approach is the approach of business intelligence or BI approach, right? Or business analytics approach. And this is something that we see some organizations using this kind of approach, and we'll explain why. Okay? So generally speaking, what is a business intelligence approach? A business intelligence approach is something that we've inherited from business analysts in order to basically track KPIs and business metrics through the use of dashboards, right? And that's something that is very useful for analysts to do. And basically what that means is it means that we take the outputs of the models after production and we we design customized metrics, right, that we want to track. So maybe we want to track, kind of like the prediction scores of the models. Maybe we want to track, various kind of like performance metrics that we care about, and then we throw them into dashboards that we can monitor. Right? The reason that we see the community using business intelligence or business analytics approach is because it's very easy to set up. So probably the next step after you have after you've tested a model, right, in a notebook or a Databricks notebook, right, you can very easily kind of connect the output of that model into a dashboard. Okay. The advantages are it has no context, and you need to know nothing about machine learning or AI in order to do this, right? Because you can treat the just performance metrics, right, of the model as just a KPI that you're tracking, right? And in addition, there are a lot of really great open source tools that allow you to kind of build these dashboards very quickly, right? And makes it like extremely easy to set up. So this is something that you can ask a data scientist, a good data scientist, to probably set up in within a day or two. However, when we're thinking about like what we actually want to achieve with like ML integrity, right? It's not ideal, right? So I'll try to focus on kind of 3 main reasons for why this is not ideal. One reason is because it's very, it basically reports on failures, but it doesn't prevent failures, right? So if you think about like the difference between, this tells you that your house was on fire last week, right? But doesn't necessarily prevent the fire, right? Because we're connecting it to the model output, right? So it tells you, right, like after, performance has already gone down. Now, because of the way that this is set up, it's very difficult to standardize quality across an organization. Specifically, right, if you think about what this approach says, is it basically says that we're setting up, a data scientist set up her own thresholds, right? And then basically looks at when these thresholds are not being met, right? So now if you have an organization that has, tens or hundreds of data scientists and, tens or hundreds or thousands of models, right? It's extremely difficult to sort of have a standardized way of having everybody, set up their, kind of the same kind of like metrics or thresholds. And finally, when we're thinking about scale, right, having a, basically requiring a data scientist to like set up every one of these thresholds themselves, right, is something that doesn't automate or scale when we're thinking about tens or hundreds of models, right? So that's kind of like the main challenge that we're facing whenever we're taking this sort of business intelligence or business analytics approach. So what's the alternative? The alternative is to look at what our friends at software engineering and cybersecurity are doing, and basically to take a testing-driven approach, right? It's conceptually it's very, very simple, right? Testing-driven approach basically says that we write tests of all these AI risk symptoms that we care about, so that we can automate these tests, right? And just kind of like run hundreds of tests on models and data, right? That are basically like auto-configured from based off of the performance of the models. So if we think about like kind of very like at a high level, right? What would this mean? So when we're at the data engineering stage, we take in a data set, we run tests on the actual data to sort of identify whether there are any issues, right? And we can spit those out into a nice UI. So this is a UI that we have the product at Robust Intelligence, and what this UI is looking at, the tests, like we're running hundreds of tests, right? And here we're zooming in on a test of unseen categoricals, right? So we're looking at, are there any unseen categoricals in the data, right? And if there are, we're looking at what is the effect that these unseen categoricals have on the model performance, right? If they don't affect the model performance, maybe we don't care, right? But if they do affect the model performance, this is when we should care. And that's a test that's being run automatically, right? As a part of a CI/CD process. Next up is when we have like the model building part. Now we actually have a model. Again, the model hasn't gone into production yet, but we can now start testing the model, right? So now we're taking input from the data tests and the input to the model, and now we're running tests on the actual model. And here, for example, like continuing with this example of unseen categoricals, right now when we're looking at the model, we can look at and say, how does the model, we've seen that there may be unseen categoricals, and now we can look at the actual model and sort of test, how does the model respond to unseen categoricals? So we can introduce unseen categoricals and various features, right, and test the sensitivity or the robustness of the models, right, to this unseen categoricals, right? And again, we can automatically, right, get the impact that this has on the model, right, and based off of that, decide whether this test is passing or not passing. So now that we've done that, and it gets a little bit more intricate than that, we can test for like feature engineering, and we can test for like other things. But conceptually, now we're moving the model into production. And now that we're moving the model in production, we can now actually start protecting the model, right? And this is when we build something that we call Robust Intelligence and AI Firewall. So what we do is we compile these results from the tests, right, into something that wraps around the existing model. So now, whenever data is coming in live into the model, we can test in real time, are there any issues, right, in the data that can affect the performance or the decisions of the models, right? If we think about the case of unseen categoricals, right, we've identified that the model is maybe susceptible or vulnerable to unseen categoricals, right? And whenever there's a data point that comes in with an unseen categorical, what we can do is we can flag it, block it, or impute it. And again, we have like this nice UI view that tells us here are all the data points that have failed in real time, right? And we can now double click and dig into these and see exactly what is the issue. And the issue is the failing test. So we kind of like have that explainability for free. And then again, once we have once we have the model deployed, we have prediction logs, and now we can apply continuous testing, right? This is when we're running a CI/CD process and just continuously testing the performance of the model. And again, we can sort of use this for monitoring and sort of see whether there are any issues. And now we're not only looking at performance issues or things that are like dropping or not dropping with the model, but what we can actually do is we can actually kind of continuously run these tests and see what is the nature of these failures or issues, right? So basically that's from this very kind of like very, very simple concept of tests, right? We can build an entire system. Somebody can literally write like one test, and the framework basically generates an entire system that can take that test from like data to model, right, to like firewall, to continuous testing for monitoring, right, to kind of give you end-to-end machine learning integrity, right? So irrespective of whether you're using robust intelligence or not using robust intelligence, I'm still an academic. So as an academic, the testing-driven approach is something that I highly recommend, and I think that we at Robust Intelligence highly recommend as well. So what does this look like in a Databricks native environment? Because again, this is why we're all here. So basically, if you think about like a Databricks notebook, and you can now sort of imagine a data scientist that's running a couple of training like different models. So this is what it would look like, and then they can look at kind of like the metrics, the standard metrics that they have, right? But this is maybe something that that is not enough, right? So basically now, we can go in and do kind of the normal procedures the data scientist does when kind of training a model on the Databricks notebook, right? So you can do the model training, you can do the model evaluation, right? And you can log the experiments in MLflow, as you do. But now, what we're doing is we're adding an additional step through the Databricks notebook, right? And in that additional step now, we're actually deploying the stress testing, and that's what we're seeing down here, right? So by the way, we have a partnership with Databricks, so pretty soon you'll all be able to kind of just use this automatically, right, as part of running this with your notebooks. Okay, so you get notified whenever this, on Slack, whenever the testing is done, right? And now you can you have all these new metrics, right, that you can look at in your notebook, right? And the interesting thing is that these metrics are not just about model performance, but now they're about robustness and different issues, that we have that can come up with a model. So again, in the notebook, you can kind of dig into these tests. You can dig into the metrics, and then inside these metrics, you can actually scroll, kind of click down and look at the actual tests, what sort of features they've been run on, and how they were used, right? So this is part of like a CI/CD process, right, that any data scientist can run right now that they're as part of like just training a model with a Databricks notebook, right? So there's really kind of like no overhead in doing that, right? And you just have kind of like a very good kind of like automated testing, right, for the models. And of course, all this graduates into, you can also look at this in the Robust Intelligence UI. You don't have to look at it in the Databricks notebook, and you can kind of like dive in deeper and kind of see more analytics and things like that. Okay, so that's kind of like what it would look like in a Databricks native environment. So how do customers actually use it? So let's see. So Expedia, for example, right? We're talking about an organization, obviously that we all know, in a race travel reservation website. They process like, billions and billions of transactions, right, by the minute, right? They have hundreds of models, right? And they have a very high bar for ML integrity, right? So how does an organization like Expedia, right, kind of manage this whole thing? So the main challenge is that, like machine learning is rapidly scaling at Expedia, right? And they're increasing the number of models that they have under their purview, right? Data science time is really, really valuable, right? And we don't want to waste it on firefighting. And we have like kind of multiple teams across, from Seattle, Geneva, across the globe, right, that are basically developing and deploying all these models, right? And these errors, they introduce risk to the organization, right? And eventually they can hurt business KPIs and the end users. So something, if we think about, just from like what does the solution look like? So automated end-to-end testing from implementation all the way through monitoring, built-in integrations with ML development cycle, NLP and tabular support that's being used at Expedia, and integrated results into business dashboards. And Expedia we chose Expedia here because it's a very big Databricks customer, and this is roughly kind of like what the pipeline looks like, right? So again, conceptually, AI stress testing of robust intelligence is being used to connect with in the data preparation phase, right? Connect with ML Flow and kind of like the Databricks notebook that we've seen, right? And in the production phase, connects with the real-time kind of like model protection and batch analysis for continuous testing. Another example that we have is a very large HR and payroll tech company. They manage kind of the services, they're industry leader in payroll and HR solutions. They provide businesses kind of like for outsourcing services, analytics, compliance expertise, right? And they're trusted over, say, hundreds of thousands of clients worldwide, ranging from like small businesses to large businesses. The main challenge that this organization is facing is not only scale, but is also basically regulatory and compliance. So whenever you're operating in a massive, massive like HR payroll, you want to ensure that there's really no bias in your models, and you want to comply with regulation. Recently, New York City introduced a law that requires regular audits for automated employment decision tools, right? So it applies here. And the EEOC recently introduced guidelines that are requiring testing and continuous testing of models, to make sure that they don't have any bias and discrimination on protected features, right? So now you have like multiple teams, building models, right? And sort of if you want this kind of thing to scale, then you have to go with an automated testing approach. So here, like, they're basically using compliance-focused testing suites, gives them auditable pipelines with kind of like clear reports, surfaces kind of like the most important issues, that may come up when it comes to like kind of bias and performance. And basically, they have like very rich APIs that the product integrates with. And finally, they're using kind of like these model scorecards, right, giving them kind of like all the reporting capabilities that they need. So here, the pipeline looks, I think, similar to what we've seen from Expedia. Again, very, very large organization, heavily uses Databricks, right, in kind of in a sophisticated way. All right, so just kind of the main takeaways. So I think that one of the takeaway number one is I think that one of the biggest pains of getting ML into production is AI risk, and that's a pain that I think that will just not go away, and this is going to be kind of like driving the main focus of, I think, the AI and data community. Another one is that whenever we're thinking about failures, and this is what we said before, we should not think of like bias, bad input, drift, adversarial input as different challenges that we have to kind of fight individually. Really, how we need to think about them as symptoms of the larger problem, and that larger problem is AI risk. Okay? And then finally, I think kind of the goal of this talk was to try to convince you that a testing-driven approach, whether you're using robust intelligence or kind of want to develop something else, right, is really the way to go if you want to introduce end-to-end machine learning integrity into an organization, making it free of AI risk. So with that, I'll conclude, and thank you all for coming. Thanks.
Okay, thanks. Thanks very much, Yaron. Do we have any questions from the crowd? Yes, I'll give you the mic. Hang on.
Hi, thank you very much for that talk. My name is Christian. I'm from Standard Chartered. I'm a data scientist. My question is, what about the unknown unknowns? So you can test for all the things that you can anticipate, but things can still happen that might not be on the agenda yet.
Yeah, and I agree, right? The unknowns is always a problem, and we're limited, right, in what we're testing, right? Because by definition, we're only testing for the, right, for the risks that, that we can anticipate. I personally don't have an answer to that, right? And I think that, like, if we look at, like, the cyber community, the cybersecurity community, right, they haven't come up with an answer for the unknown unknowns, right? So I think we're, in that sense, we're kind of in the same boat, right? The best that we can do is we can basically have kind of like industry-leading practices, right, to sort of have large coverage, right, and make sure that, like, whatever we do generalizes in the best possible way, right? But there, is it possible that we'll develop like a new kind of type of model, like maybe like a sophisticated reinforcement learning models that are going to have, like, various data leakage issues that we haven't recognized to test for? Absolutely, it can happen. But the best that we can hope to do is to catch that quickly, right, and then kind of be able to disseminate that across the industry.
Yeah, thank you. I agree. I think in order to catch that quickly, wouldn't it be good to have a combination of the test-driven approach plus the BI approach, like, rather than choosing either, having both?
I mean, we haven't, I think from our perspective, we haven't found a kind of a business analytics approach. I think that once you have a testing-driven approach, then you probably don't need a business analytics approach. But, by all means, if somebody wants to kind of do more experimentation and kind of like, then I can, that could make sense. Yeah.
Cool. Thank you.
I think we've got time for one more. You, sir?
Hi, I'm Max. I work in healthcare for a medical robotics company. What do you advise regulators, or what do you envisage regulators requiring if deploying AI in a more regulated field like healthcare?
Yeah, so probably in your industry, you're facing FDA regulations, and FDA has concrete regulations on usage of AI that requires testing and auditing. So we can talk more offline, but basically we have quite a few like healthcare customers. Some of them are in medical devices and other areas, and basically they're using the product to automate testing required for FDA regulation. They're reporting that they've been saving like a year or two of time in terms of like data science, and also a year or two of like time in terms of like getting FDA approval, right? So they're able to accelerate that process. So yeah, that's definitely a focus area for us, and one that we've seen testing-driven approach being very valuable, for sure.
One more, okay.
Good morning, I'm Jacopo. Thank you for the speech. Mine is more a clarification than a question. How this tool is combined with Databricks? Is like that you run another notebook, or how it is merged with the Databricks?
So just make sure that I understand the question. So the question, like, how does this merge with Databricks?
Yeah.
Yeah, great question. Yeah, so I think, as we all know, like Databricks offers like an amazing suite of MLOps products, right? All the way from like notebooks to like, MLflow, repositories, and all this. So basically the way that we kind of the TLDR is that basically everything that you've seen here has APIs, right? And you basically can like integrate that with, with Databricks notebooks. You can integrate that with, like ML flows. You can integrate that with like repositories, just across the board. Yeah.
Okay, thank you.
Sure.